A very good morning to all of you. So in this video we'll be covering a very important solid state question of IIT JAM which was asked in year 2015. Right, it's a very important question. It's not a trickier one, but it's quite lengthy question, right? So you have to go step by step in order to get to your right answer, right? So without wasting much of your time, let's begin with our video, right? So what's the question say? Let's try to understand that, right? The ionic radii of cesium positive and chloride minus ions are 181 and 167 picometers respectively. The Born exponents for helium, neon, argon, krypton and xenon configurations are 5, 7, 9, 10 and 12 respectively, right? If the values of A Ne square by 4 pi epsilon naught is 2.45 into 10 to the minus 4 joule meters, the lattice energy in kilojoules per mole of cesium chloride according to Born-Landis equation is this, right? So they have given your values of radius, right? They have given your values of radius. They have given the values of Born exponential also. Generally, it's not given in the question. You have to remember it by yourself, but they have mentioned it, right? The Born exponents of your noble gases, right? And they have given the value of this particular combination, which is a part of your Born-Landis equation, right? So you have to find the Born-Landis. You have to find the lattice energy in kilojoules per mole, right? Right, this is very important. You have to find the energy in kilojoules per mole, right? So never forget the units, right? According to Born-Landis equation, right? So these all are the values given for Born-Landis equation, right? Okay, so these all are the values given for your Born-Landis equation, right? And we all know that this is your Born-Landis equation, right? Del U equals to A Na Z positive Z negative E square 4 pi epsilon R 1 by 1 minus N, right? So this is the value of your Born exponent, right? And this is the value. A is representing your Madeline's constant, right? Now generally students get confused between the minus sign, right? Whether to put minus sign here or not, right? So it's quite obvious, right? If you are putting minus sign before this equation, right, then you have to take the mod of your charges, right? Then the product of your charges will be positive, right? And if you are not putting in minus sign here, then you have to take the charges including the signs also, right? So it's quite easy, right? So this is your Born-Landis equation. All right, okay, so this is your cesium electronic configuration of cesium positive is your argon, electronic configuration of argon, and electronic configuration of chloride ion is electronic configuration and argon again, right? So for argon n value is 9, right? You can see for argon n value is 9, that is a Born exponent's value is 9, and for chloride is also having your electronic configuration of argon, so again the value of Born exponent is 9 again, right? So the average of 9 is 9, right? So whenever if somehow you get the different values of Born exponent, so you have to take the average only, right? So here both the Born exponents are equal, so their average is also equal. That is the Born exponent for cesium chloride is 9, right? Right, so this is the value of your Born exponent, right? Okay, now this is the value of your radius, right? So radius of your molecule is, or your solid is, radius of cesium positive and radius of your chloride ion, right? So the radius of your cesium positive and radius of your chloride ion. Right, so radius of your cesium positive is 181 picometer and of chloride ions 167 picometer, right? So radius is equals to 348 picometers, right? Now the units of radius is picometer, and we have to find the values in meters, right? So we have to convert this picometer values to meter, right? So 1 picometer is equals to 10 raised power minus 12 meters, right? So we have to convert these values to meters only, right? Now this is your Born-Landis equation, right? Now we have arranged the Born-Landis equation in such a way that we can find the values easily, right? So as you can see, this is the Born-Landis equation, right? One second, let me, yeah, so this is your Born-Landis equation, right? So we have arranged Z plus E square 4 pi epsilon naught because this value is given only, right? And we have to substitute the value of your radius, right? So radius we found out is equals to 348 picometers. So yeah, this picometer would not be here, it's written in the denominator. One second, right? So this picometer is written here only, right? This picometer is written here only, right? All right, anyhow, so this is your Born-Landis equation, right? And this value is already being mentioned in the question, right? And this value we have calculated here, right? And the minus sign here denotes the charges, right? As we haven't taken the charge negative outside this Born-Landis equation, so we are considering the charge of your charge of your chloride ion also, right? So it's 1 into 1 is 1 for your cesium positive and -1 for your chloride, so it's -1, right? And we found out that the value of your bond exponent is 9, so 1 minus 1 by n, that is 1 minus 1 by 9, right? So this is your basically the mathematical equation which we got after solving this bond Landis equation, right? And if you substitute the value of this particular expression which is already given in your question, so it's 2.45 into 10 to the minus joule meters, right? And you have calculated the value of your radius, so it's equals to minus 1 by 348 into 10 to the minus 12 meters, because we have to make the unit same, right? So we have converted your picometers into meters, and it's 1 minus 1 by 9, right? So when we solve this equation, right, now the point over here is about the units, right? So you have to get the answer in your kilojoules per mole. So what you will do, let me tell you here, right? So we have to convert your units, so this is done by this method, right? So the meter from here and meter from here get cancelled, so you are left with your joules, right? So we have to make the units in kilojoules per mole, right? So we have to make it first in joule per mole, right? And as we know, if we'll multiply this joule with your Na, that is your Avogadro's number, right? Avogadro's number. So the unit of Avogadro's number is your mole inverse, right? Mole inverse, and the value of your Avogadro's number is 6.023 into 10 to the power 23 mole inverse, right? So you'll get the value in your joule per mole, joule per mole, right? And if you divide this value by 1000, right, in order to get the values in kilojoule, so you'll get the value in kilojoules per mole, right? So this is how you can do the unit conversion thing, right? So this is how you can change the unit. So it's all about the unit conversion. In physical chemistry you have to be very careful with the units, right? So alright, this is how you can change your unit. So you are left with this equation of bond Landis equation, and after solving this equation, right, yeah, I have written over here that you have to multiply this thing by Na, that is your Avogadro's number, which is 6.023 into 10 to the power 23. You'll get the value in joules per mole, and if you divide the value by 1000, you'll get the value in kilojoules per mole, right? So your del U, that is your lattice energy, would be minus 625.8 kilojoules per mole, right? So this is your lattice energy. You have to look out for options, right? You have to see whether it's given in positive and whether it's given in negative, right? So accordingly you have to take the answer, right? So this is all about this question. It's a very simple question but a lengthy one, right? So you have to be very careful with your steps.